Picture this. You've spent weeks taking care of your plants. You've dialed in your nutrients, your lighting, your growing medium, and something still isn't right. Leaves are yellowing, growth has stalled, and you have no idea why. What if I told you the #1 culprit, the one nobody talks about, is the water you've been using all along? The wrong pH locks out nutrients even when you're feeding perfectly. Chlorine wipes out the beneficial microorganisms living in your substrate. Dissolved minerals compete with everything your plants are trying to absorb. And the worst part? Most growers never check their water. They just pour it in and hope for the best. In this video, we're going to cover everything you need to know about water for your crops: pH, chlorine, minerals, and water quality. Because water isn't just water, it's the foundation of everything you grow. Welcome to Genetics Growers. Before we dive in, we just want to say thank you for being here and for taking the time to learn and level up your growing game. That's exactly why we created this channel, to give you the right information, practical, no fluff, no filler. And if you didn't know yet, we also have a blog on our website where we cover a ton of topics: growing techniques, pest control, agro trends, step-by-step guides, and a whole lot more. We'll leave the link in the description so you can check it out whenever you're ready. Today, we're tackling a topic that sounds simple but has a massive impact on your results: water. And we're not just scratching the surface, we're going deep. pH, chlorine, minerals, and how to know whether your water is helping your plants or quietly working against them. Stick around until the end, and you'll walk away with real, actionable tools to test and improve your water starting today. Let's get into it. Water is the main vehicle through which nutrients enter your plant. No water, no absorption. But here's the thing. It's not just about quantity. The quality of that water determines whether your plants can actually use what you're giving them. Think about it this way. Let's say you've mixed the perfect nutrient solution, ideal ratios of nitrogen, phosphorus, and potassium. But your water's pH is off. What happens? Those nutrients are sitting right there, but your plant can't access them. It's like having a full meal on the table with the fork locked away. The 3 biggest factors that affect water quality for growing are pH, chlorine, and mineral concentration, also known as dissolved salts. Each one impacts your plants differently and can create problems at different stages of growth. On top of that, your water source matters. Tap water, well water, and rainwater all have very different compositions, and each needs to be treated differently. In many cases, a simple water test can save you weeks of headaches and real losses. Let's start with pH. pH is a scale that measures how acidic or alkaline a solution is. It runs from 0 to 14. 7 is neutral. Anything below 7 is acidic, and anything above 7 is alkaline or basic. For most soil and substrate-based crops, the ideal pH range for your irrigation water is between 6.0 and 7.0. For hydroponic or coco coir setups, you'll want to dial it in a bit tighter between 5.5 and 6.5. So, why does this number matter so much? Because every nutrient has a specific pH window where it can actually be absorbed by the plant. If your pH runs too high, micronutrients like iron, manganese, and zinc become insoluble. They're technically in the water, but your plant can't take them in. This is called nutrient lockout, and it's one of the most common and most misdiagnosed problems in growing. On the flip side, if your pH drops too low, macronutrients like calcium and magnesium become unavailable, and you risk burning your roots with excess acidity. How do you measure pH? You've got 2 main options: a digital pH meter, which is the most accurate, or pH test strips, which are cheaper but less precise. If you're growing seriously, a digital meter is absolutely worth the investment. And if your pH is out of range, how do you fix it? With pH up or pH down solutions, simple acid or base products that let you adjust your water before you water your plants. One key rule: always adjust pH after you've mixed in your nutrients, not before. Pro tip: Measure your pH right before you water, not when you first prep the solution. Some fertilizers and environmental factors can shift the pH over time. Next up, chlorine. The villain or hero, depending on the context. Most municipal tap water contains chlorine because it's used to disinfect the water supply and make it safe for us to drink. Makes total sense for humans. For your crops? Not so much. Chlorine in your irrigation water has two main negative effects. First, it kills or disrupts the beneficial microorganisms in your soil. Those bacteria and fungi work quietly in the background, breaking down organic matter, fixing nutrients, protecting your roots. They're especially critical in organic grows and living soil setups. Second, at higher concentrations, chlorine can directly damage root tissue, burning the most delicate parts and reducing your plant's ability to absorb water and nutrients. That said, let's be fair. At very low concentrations like what you typically find in city water, the impact may be minimal, especially in conventional grows using inert substrates. There's a big difference between watering with tap water at 0.5 ppm of chlorine and using heavily chlorinated pool water. So, what do you do about it? The fixes are actually pretty simple. The most basic, let your water sit in an open container for 24 hours. Chlorine is volatile. It off-gases on its own when exposed to air and light. A faster option, vitamin C, also known as ascorbic acid. Just a tiny pinch in your water neutralizes chlorine in minutes. There are also water conditioners specifically made for growing that do the same thing. Now, if your water contains chloramines, a more stable form of chlorine that does not evaporate with time, you'll need activated carbon filters or a specific chemical treatment to deal with it. To find out which one you have, you can contact your local water utility or use a water test kit. The third key factor is the concentration of minerals and dissolved salts in your water. This is measured using two units you've probably heard before, EC and PPM. EC stands for electrical conductivity. It measures how well your water conducts electricity, which tells us indirectly how many dissolved salts and minerals are in it. PPM stands for parts per million, and it's just a different way of expressing that concentration. The two are directly related. Higher EC means higher PPM. Why does this matter for growing? Because plants can only absorb nutrients within a certain concentration range. If your tap water already comes loaded with dissolved minerals, what we call hard water, it can interfere with the nutrient solution you're trying to build. You're essentially adding a layer of salts you didn't plan for, and they can block or compete with the nutrients you actually want your plant to take up. Ideally, you want to start with water that has the lowest EC possible. Less than 0.5 millisecond per centimeter is a solid benchmark. That gives you a clean slate and full control over what you're feeding your plants. Well water tends to have high EC. Rainwater typically has very low EC. It's about as pure as water gets naturally. Tap water varies quite a bit depending on your region and source. If your local water has high EC, the most effective solution is reverse osmosis, or RO. An RO system strips the water down to near zero EC, giving you that blank canvas. Ion exchange filters and resins are another option, though they tend to come at a higher cost. One mineral worth calling out specifically, calcium and magnesium. Hard water tends to be loaded with both. They're essential nutrients, but in excess, they throw off your nutrient balance and can block potassium and other elements from being absorbed. The takeaway: test your water's EC and PPM before you use it. EC PPM meters are inexpensive and one of the most valuable tools you can have in your grow space. We've covered pH, chlorine, and minerals. Now comes the practical question. How do I actually know what's in my water, and what do I need to fix? The first step is a water test. You've got two routes: a basic DIY test using your own tools, or a full lab analysis. With your own tools, you can measure pH with a digital meter or test strips, EC and PPM with a conductivity meter, and chlorine with reactive strips or a colorimetric test kit. That's already a solid picture of what you're working with. If you want to go deeper, especially if you're using well water or you're seeing unexplained problems in your plants. A lab analysis will tell you exactly what minerals are present, at what concentrations, and whether there are heavy metals, bacteria, or other contaminants in the mix. Many agricultural or water testing labs offer this service at very reasonable prices. Once you know what you've got, you can take action. Here's a quick rundown of the main corrections. For pH, use pH up or pH down, always after mixing nutrients. Adjust in small increments and retest each time. For chlorine, let it rest for 24 hours, add vitamin C, or run it through an activated carbon filter if you're dealing with chloramines. For high EC, dilute with purified water, run it through a reverse osmosis system, or use specialized filters. For very pure water, like RO water with near zero EC, make sure to add a CalMag supplement before use. Ultra-pure water can actually pull minerals out of your roots through osmotic pressure, so a small amount of calcium and magnesium is essential to stabilize it. The bottom line: perfect water doesn't exist everywhere. What matters is knowing your water, understanding its characteristics, and adjusting accordingly. That's the difference between a grower who guesses and a grower who knows. And that covers everything you need to know about water for your crops. Let's do a quick recap before we wrap up. The ideal pH range for most soil and substrate grows is between 6.0 and 7.0. For hydro or cocoa, aim for 5.5 to 6.5. Always measure before watering and adjust if needed. Chlorine in tap water can harm your beneficial microorganisms. Let it rest for 24 hours, use vitamin C, or run it through a carbon filter, especially if your supply uses chloramines. EC and PPM tell you how many dissolved salts are in your water. Start with low EC water when possible, and use reverse osmosis if your source runs high. And test your water. Whether it's with a basic meter at home or a full lab report, knowing what you're working with is the first step to controlling it. If this video helped you out, the best thing you can do for the channel is hit that like button, drop a comment below with your questions or your own experience with water quality, and subscribe so you don't miss what's coming next. We put out new content every week to help you grow better. And don't forget, we have a blog on the Genetics Growers website packed with in-depth articles on growing techniques, pest control, practical guides, agro trends, and a whole lot more. Everything in one place, so you can keep learning at your own pace. The link is right there in the description. Thank you so much for watching, for your time, and for being part of the Genetics Growers community. We'll see you in the next one. Take care of those plants!